The French and Indian War consisted of a struggle... Wait. Am I in the right video? That's more like it. Ah, the gene. You've heard about it in your biology class, right? Mendel and his peas? Well, it's a tad bit more complicated than that. There's introns, extrons, operators, operons, promoters, polymerase, chromatographs, RNA, ribosomes, protein. It can get a little bit overwhelming. Now, what you pretty much need to know is the central dogma of biology. From DNA, RNA, proteins, to expression. DNA. We all have it. In fact, we have over 2 meters of DNA in every single cell. Its main components are 2 sugar phosphate backbones and 4 nitrogenous bases that pair accordingly to Chargaff's rule. These small nitrogenous bases are everywhere. In fact, we have over 3 million of them inside our cells. However, scientists have found that only 1% of all these nitrogenous bases of all of our DNA is actually active or functional. It's quite a puzzler, but think about it for a second. But moving on, from DNA to RNA, small molecules will read the DNA and make a half copy we know of as RNA. Half copies then find their way out of the nucleus and into the cytoplasm, where they meet up with their good old friend, the ribosome. Now, the ribosome you can think of as a baker. Whatever recipe he's given, he'll make. Thus, whatever recipe this half copy of DNA gives to the ribosome, it'll make, and this is known as a protein. And there we go. This process is what makes you and me. It occurs within all of us. But if you're anything like me, you're still hung up on how so much DNA can fit inside a cell and why only 1% of it is active or working. What's the rest of that DNA doing? Well, we can thank our other friend, epigenetics, for that one. Epigenetics describes how outside forces influence our DNA and how our DNA is expressed. Now, what we didn't discuss about DNA is that it's tightly wound around these proteins called histones. Now, just like headphones in your pocket, you wind them up to prevent tangles. If they weren't wrapped up, they would just get extremely messy, and then it's a mess to try to untangle them. But here's the thing with DNA. As it's continuously wound around this histone or this small little ball, the stuff in the middle is going to get harder to access. There's nooks and crannies that won't be able to call over this molecule that will in turn convert it to this half copy or RNA and then proteins, and it won't be expressed. But imagine there's some aircraft marshals all around your DNA. They're going to call over this molecule like an airplane to convert it to RNA at specific points within the genome. Thus, genes with only active marshals, the ones that are actually doing their job, will be expressed. Because if the rest of the genes don't have a marshal to call over that molecule that converts it to RNA, then proteins, then it won't be expressed. Now, with that concept, if you wanted to express something much more, let's say brown hair, you wanted to make even browner hair, then you would just add more genes that code for the brown hair, right? Then they would go through the whole dogma of biology, RNA, proteins, and be expressed. Now, this was the mentality of a fellow group of researchers at U of A, but they were looking to make a petunia even more purple than it already was. It was to their surprise, however, when this wasn't the case. After they introduced more purple genes inside the flower, it turned out being completely white. No purple proteins were being expressed at all. But how does that make sense? 1 gene plus 2 gene equals... oh yeah, more DNA to be expressed. Well, it's all thanks to our good old friend epigenetics again. It turns out that when researchers added this gene to the DNA, the cell didn't like that. It saw this gene as foreign, something that shouldn't be inside the cell. So a long time ago, it developed this mechanism in which it could chop up anything new that came inside the cell that was foreign. It would then use a small piece of that to survey the rest of the genome. Think of it as the police. These small fragments that they use to survey the genome can be thought of as a caricature. And once the police get a hold of the caricature, they can search the town and the city for this specific criminal. And if they get a hold of it, they'll throw it in jail and get rid of him. So in the case of the petunia, when they added this gene inside the cell and it recognized it as foreign, it chopped it up, used a small portion of that gene to survey the rest of the genome, and whenever it saw anything related to purple being expressed or a purple protein, it totally chopped it up and killed it! And thus, a white petunia. Now, this is known today as RNAi, or RNA interference, and researchers use it all the time to turn off genes. In fact, researchers often turn off all the genes within the genome and slowly turn them back on, so they know what gene is doing what and what protein it's expressing. It's all very exciting. Well, at least for nerds like us. So let's give a round of applause to our good old friend Epigenetics. He does so much inside the cell, it's bonkers. Just remember, it's a little bit more complicated than DNA to RNA to protein to expression. There's a lot of variables that can influence how a protein is expressed and whether it's expressed at all. I guess you could say that was epic. I'll leave.